Hello and welcome to the OpenSAP course Building Apps with the ABAP RESTful Application Programming Model, Week 3, Unit 4, Entity Manipulation Language. My name is Volker Drees and I'm a product expert for the ABAP RESTful Application Programming Model. In the previous units, we used the ABAP development tools to create the base behavior definition and the behavior definition projection for our travel business object. In these behavior definitions, we made use of the standard create, update and delete capabilities that do not require an own implementation as they are managed by the RAP managed runtime. In this unit, we give an introduction into the entity manipulation language that you will need when you, for instance, add determinations, validations or actions to your business object behavior definition. The entity manipulation language, in short EML, is part of the ABAP language and allows you to interact with your own and other business objects in a SQL-like syntax. It allows you to control the business object's behavior in the context of the ABAP RESTful Application Programming Model. The EML also gives you API-based access to other RAP business objects. The standard EML provides a type-safe read and modifying access to data and transactional development scenarios. This is the most common use case. For generic implementations, for example, when developing own frameworks, you can also use a generic EML implementation. The ABAP runtime ensures the transactional consistency similar to the logical unit of work that you know from SQL. The first operation that we will look at is the read operation. It allows to perform a transactional read of business object instances. Transactional read means the read is taking place from the transactional buffer. If the instance is not present in the buffer, it is automatically read into the buffer from the database by the managed runtime. As all EML statements are mass enabled by default, you need to specify a table of keys for which you want to perform the read operation. This allows you to perform the read for a set of instances with a single EML call. Next to the actual result, EML statements also provide failed and reported information. They reflect keys for which the requested operation could not be executed. For example, reading a travel instance that does not exist. Reported optionally contains explanatory information like T100 messages. The modify operations are used to perform changes to the transactional buffer. If a record is not present in the buffer, it is read from the database before the operation is performed. The modify create is used to create root instances. Via the so-called create by association, it can also be used to create child instances along associations. Please note that EML operations are executed on the transactional buffer. They are only persisted to the database when the commit entity statement is performed. The modify update is used to update instances. You can also update instances that have been created before and are not yet persisted to the database. For this, you need to make use of the content ID. The modify delete is used to delete instances. The modify execute operation is used to execute actions. In contrast to functions, actions may change data and are therefore performed as part of the modify operations. Now let's go into the system, create a small class and perform some EML calls on the existing data. Right-click on your package and select New ABAP class. Enter the name ZCL, RAP, EML and your group ID and provide a meaningful description. Click Next. Assign a transport request and click Finish. In the public section, add the interface IF ADT class run. Use the quick fix to add the implementation for the main method. The first EML example performs a read operation. For this, we make use of the read entity statement followed by our RAP travel business object. Then we need to specify the entity for which we want to perform the operation for. In our case, the travel entity. As all EML statements are mass-enabled by default, we need to specify a list of keys for which we want to perform the read operation. The result of the read will be put into the inline declared table travels. And finally, we make use of the console to show the content of the result table. Before we can proceed, we need a travel UUID. Open the table preview of your travel table and pick a UUID that you want to use in this example. Double-click the value to pick just the UUID. Remember the associated travel ID so that you find the record back later on. Paste the UUID into the placeholder. Save and activate and run the class as a console application. The read is performed, but only the key field is filled. This is because we have not specified the fields we want to read, and the keys are provided by default. In the next example, we name the fields we want to read by using the fields addition. Save and activate and run the class as a console application. Now the agency ID and customer ID are also provided in the result. It's also possible to read all fields of the entity by using the all fields with addition. Save and activate and run the class as a console application. Now all fields of the entity are returned. Another option is to perform a read by association following the association defined in the behavior definition. Save and activate the changes and run it again as a console application. As a result, we get all bookings with all fields associated to this travel. When performing EML read operations, you should not only consider the result table, but also take the failed and reported tables into account. Failed is used to convey unsuccessful operations. Reported is optionally used to provide related T100 messages. Let's try to perform a read of a UUID that does not exist. The result table is empty. The failed and reported table are nested tables and are not supported by the console output. So let's put a breakpoint and check the content of the tables. Failed contains an entry for the unsuccessful read with the fail cause not found. The reported table is empty as the fail cause sufficiently explains the reason. Now let's take a look at modifying operations. Let's perform a modify, updating the description of our travel record. Save and activate and run the class as a console application. Use the Fiori Elements application to check the updated description. As we can see, the description is still the old one. This is because we have not performed a commit of our changes. Add the commit statement. Save and activate and run the class as a console application. Check the result in the Fiori Elements application. Now let's create a new travel record by using the modify create statement. Activate and run it as a console application. Check the result in the Fiori Elements application. For operations creating instances, a mapped table is returned, which maps the created instance to the provided content ID. Deletions are performed using the modify delete statement. Activate and run the class as a console application. Check the result in the Fiori Elements application. The deleted record is gone. Actions can also be executed using the entity manipulation language once actions are defined in the behavior definition. That was it for the system demo. We are now at the end of this unit. Let me do a short recap. In this unit you have learned about the basic syntax of the entity manipulation language and how it allows you to read and modify transactional data. Further information for this unit is available in the appendix of this presentation. Thanks for listening and see you in the next unit where we enhance the behavior of the travel business object and subsequently use EML to implement the corresponding business logic.